Relations. A relation is a set of ordered pairs or a table of ordered pairs. As long as those ordered pairs show a correlation, it is considered a relation. A relation consists of two things, a domain and a range. But how do these numbers correlate with each other? Well, that's where functions come in. A function shows the relationship between the domain and range in the relation. This relation can be showcased as this function. When you plug in the domain, you will get the corresponding range. Now that the groundwork has been laid out, let's look at the things a little bit closer. But as you know, functions can come in different forms and sizes. While yes, there are many complicated equations out there, let's look at the simplest one, the linear function. The linear function is a simple function because, as the name suggests, it's linear. And it's linear not just conceptually, but also graphically, as you can see right here. On this equation, m stands for slope. The slope describes the steepness of the line. You can see on the graph how it affects the line itself when you customize the m. And on the other hand, we have b. B represents the y-intercept of the graph. It may sound complicated, but all it does is move the graph up and down through the coordinate plane. Now let's look at an example. In this problem, you are renting a car. The car can be rented at a starting fee of $100, and every day after the first day you get an additional $10. And the problem is that you're gonna rent the car for 7 days. So how much would you owe if you rented it for 7 days? In order to solve this problem, let's look at the basics first. So right off the bat, it says that we're starting with $100. And in that $100, we're technically including the first day. And every day after that will cost $10. So the $10 per day will become our slope, while the 100 starting will become our y-intercept. So when we put all that together into an equation, we get y equals 10x plus 100, with x being the number of extra days after the first day. And since we're actually only paying for 6 extra days, we'll plug in 6 for x, and we'll end up with 10 times 6 plus 100, which we can then multiply 10 times 6 to get 60 plus 100, which will equal 160. The total cost of the rent will be $160 after renting it for 7 days.
Hi, I'm Joshua, and my topics for today are piecewise function and vertical line. A piecewise function is a function that can be broken up into many parts. So let's discuss the evaluation of piecewise function. Here is an example. So let us find a and b, which are f negative 2 and f positive 5. Let us start with letter A, which is f negative 2. We have to use the formula for x plus 5, since the x is less than 2. We then substitute the value of x. Therefore, we should have 4. Let us interchange the x, negative 2, evaluate, and then plus 5. We shall now continue on computing. So, 4 times negative 2 is negative 8 plus 5. Negative 8 plus 5 is equals to negative 3. So there you have it, the final answer. Our next problem is letter B, which is f and positive 5. The x is positive 5. Since the x here is greater than 2, so we'll use the formula 3x minus 8. Therefore, we substitute. So, the x becomes 5 minus 8. We then continue on computing. So, 3 times 5, 15 minus 8. Just bring it down. And then 15 minus 8 equals 7. Therefore, the final answer. So there you have it, the piecewise function.
Hello, editor here. I just wanted to add that this is what the function looks like on a graph. This is scenario A, and this is scenario B. As you can see, the coordinates match up with the y being the actual answer. Good job, Josh.
What is composite functions? Composite functions are those that have a given function placed inside another function. The composition of two functions, f and g, is a new function we get by performing f first and then performing g. The composite function uses the output of one function as the input of another. F of g of x means that we substitute the inner function g of x into the outer function f of x. For example, f of x is equal to 5x squared plus 3 and g of x is equal to 2x squared plus 1. So now let's find the f of g of x and g of f of x. So first, let's find the f of g of x. So to find the f of g of x, first copy 5, then substitute x into g of x, which is 2x squared plus 1, and then copy the square plus 3. Then after that, to find the square root of 2x squared plus 1, we need to use the Punnett square method. After that, we need to multiply 5 in each of these terms. So 5 times 4x to the power 4 is equal to 20x4, and then 5 times positive 4x to the power of 2 is equal to 20x to the power of 2, plus 5 times 1 is equal to 5, and plus 3. After this, we have to find the to add the like terms, which is 5 and 3. So we have the final answer, which is 20x to the power of 4 plus 20x to the power of 2 plus 8.
So hello everyone, I'm Mark Castle. In this conversation, we will delve deeper on how to find inverse functions. Of course, there is always solution in every problem, right? So the first one is replace fx with y in the given problem. Secondly, interchange x and y. Thirdly, solve for the y from the equation in step 2. And lastly, replace the new y with fe with the exponents of negative 1x. So for instance, in this given function equation is to solve or to find the inverse of it. So let's start by replacing fx with y. So it will be y equals 4x plus 3. And the second thing we can do is to interchange x and y. It will become negative 4x because it swaps with an equal sign, as well as the x. It will become negative x plus 3. The third thing is to solve for the new y. We need to divide it by negative 4. 4 with an over negative 4 will be slashed and it will become y. Negative times negative become positive, and positive times negative it will become negative, and negative times positive it will become positive. So the last part we need to do is to change y with an f with an exponent of negative 1 parenthesis x. So it will become f with an exponent of negative 1x equal x minus 3 over 4. That's all guys. Thank you for watching.
Hello everyone, this is my first graph of inverse function. What is graphing of inverse function? The graph of inverse function is the reflection of the graph of the original. The axis of symmetry is the line y equals x. The graph of the inverse function is a reflection of the original function's graph over the line y equals x. In other words, if you have a function f(x) and its inverse is denoted as f to the power of -1x, the points of the graph of f to the power of -1x are obtained by swapping the x and y coordinates of points on the graph of f(x). Remember that not all functions have inverses, and for a function to have an inverse, it must be one-to-one or injective. In cases where a function has more than one branch, its inverse may also have multiple branches. Additionally, in cases where the original function is not one-to-one, you may need to restrict its domain to a specific interval to find a meaningful inverse function and graph. For example, problem: let f(x) equals 2x minus 3 for x greater than 0 and gx equals x plus 3 over 2 for x greater than -3. Be two functions. Determine whether the functions f(x) and gx are inverses of each other. If they are inverses, find their compositions. Solution. Step 1. To determine if two functions are inverses of each other, we need to verify if f(gx) equals x and g(f(x) x for all values of x. Step 2. Start by finding f(gx). f(gx) equals f(x) plus 3 over 2. f(gx) equals 2 x plus 3 over 2 negative 3 f(gx) x plus 3 minus 3 f(gx) equals x. Step 3. Next, find g(f(x). g(f(x) equals g 2x minus 3 g(f(x) 2x minus 3 plus 3 over 2 g(f(x) equals 2x over 3 g(f(x) equals x. Since both f(gx) and g(f(x) equal x for all values of x, we can conclude that the functions f(x) and gx are inverses of each other. Additionally, you can mention that the domain and range of the inverse function are restricted by the domain of the original functions. The domain of f(x) is x greater than 0, so the domain of gx is x greater than -3, and vice versa. And lastly, the compositions of inverse functions are f(gx) equals g(f(x) equals x, which is a characteristic of inverse function. Thank you.